Okay, I asked you a question last time. Can we concatenate this two dictionaries together with a plus operator? So what's your answer? Yes or no? The answer is no. Yeah. So we cannot concatenate them together. We cannot insert another dictionary to this dictionary using a plus operator because this plus operator is not defined for dictionary. What we can do is we can call an update function because dictionary is also a set. I mean, a set of key value pairs, but at the end of the day, it's a set with specialized function, of course. But we can call update functions and insert the whole new dictionary inside dictionary as follows. Yeah. So the answer is using plus operator, no, but there is a way using update method. Great. So next, we focus on the copy function. The copy function is available for list. The copy function is available for set. The copy function is available for dictionary. So let's see the need of this copy function. Here, I want you to be very careful because that's really important. Let's say we have a list. Let's say that's a list. And by the way, the same goes with set and dictionary as well, whatever I'm going to do with list. Let's say you have a list. Now, what you do is you copy the list, or you just make another variable, like you can assign the value of L to another variable L2. What you do is that now L2 is also this. Now these are two different variables. L is this variable, L2 is this variable. So you might be thinking L2 is separately completely a new thing and L is a new thing. You might be thinking that both are independent, but Python internally manages the data structures, most of the data structures, in a way that because the data structure is a collection of a lot of data, it is consuming a lot of memory. What it does is when you assign a variable or data structure to another variable, it does not actually copy all the contents. It does not actually make a new memory and store the contents in this. It actually, this variable also actually points to the same memory as this. And the consequence of that, if you change any value, for example, in L2, let's say you change the index2 value from this, the index2 value is 4.9. Now you're working in L2. Let's say you change this L2 value from 4.9 to, let's 4.9. Let's say you do that. So you might be thinking that this happens in L2. Well, in L2, that has happened. But what it also does is it does the same thing in L as well. So L also changes. The reason is L and L2, they both are pointing to this structure in the memory. And whether you approach that structure through L or you approach that structure through L2, you're approaching the same memory anyway. And that is called referencing. I mean, it does not create the data, it actually creates a reference in the memory. It actually creates a new name for the same memory. And both are pointing to or accessing to the same memory. And if you really want the behavior so that L2 becomes different than L, and whatever I do with L2 that should not affect L, then you should call copy function. L2 is L.copy. Yeah, so that's the function, L.copy. Now you have L2. Now you do whatever with L2, it will not affect L. So L2, for example, index at index 2, you again say, okay, this is 4.9. So L2 changes. Now L2 changes, but L doesn't change. L doesn't change. L stays the same. Now this has different copy. Same concept go with the set, and same concept go with the dictionary. If you just make another variable s2 and equals to s, then if you change the contents of s2, s will change. If you don't want that, then copy it. Similarly, copy the dictionary. Because the contents of the tuple, they are not changeable, the copy function is not available for tuple. Because even if you assign this t to t2, you can now not change t2 because it is immutable. So having a copy function doesn't make sense in tuple. Great. One more thing regarding slicing. Let's say you have L that's available to you like so. That's L. And let's say you make L3 another list by slicing. Let's say a list from 1 to 5. Let's say. So you start from index 1, which is 3, and you go to 5 by not including 5. This way, the L3 is automatically a copy. It is not a sublist which is referencing. So L3 is a completely new list, a new memory view. If you change the contents in L3, for example, L3 at index 0, it should go from 3 to, let's say, 3. If you change the contents in L3, these change will not reflect in L. So if you do the slicing, slicing picks a copy by default. It does not pick a reference. And that's a huge difference between this list and a NumPy array. and we will see that when we will see a NumPy array, the slicing actually also again refers to the same memory location. And that might be one difference in indexing. Indexing in the whole Python, whenever you do slicing, you get a copy. But in NumPy, when we will see NumPy in detail, in NumPy, when you do slicing, you get again a view, not a copy. And if you change in the sliced variant, anything, the actual contents also change. And there is a reason to do that, and there are efficiency reasons to do that and stuff like so. Again, the copy function becomes much more applicable there as well. So you need to know that even if you do slicing in general in Python, in any collection, in any array, in any if you do collection for even for mutable objects like list, you get a copy. But in NumPy array, this particular thing, with a lot of other things, this indexing scheme actually changes with this kind of slicing. Okay, so I end this video here. I mean, you can explore much more functions of list, tuple, set, and dictionary, and what you can do with each of them, and in which scenario, what kind of thing is more suitable for the other. That completely depends upon the problem at hand. But what we can do in what we'll be doing in the next video, we'll be seeing some functions of just list, and then I will be just letting you to explore the tuple, set, and dictionary and all their functions on your own, and to see what function or what method is doing what for which kind of data structure. So in the next video, we will be seeing some methods just for list data structure. Hope to see you in the next video.
So by now, I'm sure you're all aware of the concept of slicing. So let's practice it. Let's say we have a list. This is our list. It contains 1, 2, 3, 4, 5 elements, right? So our task is to make a new list, L2, and copy L1 by slicing it and store it in L2. So what should be our resultant list? This should be our resultant list. So it contains end, which is the last element of L1, right? And then it should contain 9.6, which is 0, 1, 2, the second element of L1. And then it should contain start, the 0th element of L1. So figure out the way that you have to slice L1 so we can get L2. It's not difficult, it's pretty simple, and it's pretty cool actually. So try slicing, and then we'll discuss the solution in the next video. Thank you guys.